Hi, my name's Layla Tarhan, and today I'm going to tell you a bit about how the semantic embeddings of verbal descriptions can predict action similarity judgments. When we look at the actions that surround us, some of them look very similar, like running and walking, while others, like frosting a cake, seem pretty different. But what properties of these actions cause us to see them in this way? It could be that actions that look similar also share high-level information. For example, running and walking are both forms of exercise. But it could also be that lower-level visual information plays a big role. For example, running and walking both tend to take place outside, so maybe they share some spatial statistics that are different from frosting a cake. So to tackle this question, we measured the perceived similarities among a large set of everyday actions. Then we measured low, intermediate, and high-level features for these actions. And finally, we related the perceived similarities to these features to try to understand what kinds of features predict the perception the best. So to measure perceived action similarities, we showed participants 60 short videos of everyday actions. These were meant to be a really wide sample of what we see around us every day, and you can see a sample of them here. Then participants completed a multi-arrangement task where they placed still images from the videos close together on the screen if they thought that the videos were similar, and far apart if they thought they were different. This allowed us to estimate the perceived similarities among all 60 actions based off of how far apart people placed these images. So now we were curious what kinds of features might capture these perceived similarities. So we considered a whole hierarchy here. At the lowest level, we looked at computational just features, which used a series of spatial frequency and orientation filters to capture the global layout and shapes in an action scene. At a more intermediate level, we used human judgments of the body parts that are used in an action, as well as what the actions are directed at, like an object or another person. And then at a higher level, we were really interested in looking at the semantic features in these actions. But this can be pretty challenging to measure for these complex videos because they are so rich and they have so many different elements that have semantic content. So we developed a new method for measuring semantics that leans on the power of language to capture that richness. In this method, a separate set of participants watched the same videos, and while they watched them, they described them out loud. Then we passed their descriptions through a bidirectional encoder representations from transformers model, which is a deep neural network known as BERT. BERT was trained on natural language processing tests, and as a result, it can extract the logical structure and meaning from a sample of text. And it does this by embedding the text within a high-dimensional feature space. So for each video, we took the description and passed it through BERT and then extracted its embedding within this feature space and used that as a model of semantics. So now, how well can each of these feature spaces recapitulate the perceived similarities among the actions? So here I'm plotting the performance when we use similarity along each of the feature spaces to try to predict perceived similarities in held-out data. We found that the GIST model does pretty poorly, but both the body parts and action target model and the semantic features predict the behavior pretty well. And in addition, we found that both of these models explain unique variance in those judgments, meaning that they explain something about the data that isn't shared with any of the other models that we tested. That unique variance is plotted here in the dark blue and green bars. In contrast, the GIST model didn't account for any unique variance, and instead, all of its variance that it accounted for in the data were shared with the other two models. And that common variance is plotted here in gray. In a replication experiment, we found a similar pattern. Again, the body parts and target and semantic models predicted the behavior the best, and both of those models accounted for unique variance in the data, whereas the GIST model did not. So across these two experiments, we've concluded that both semantics and the intermediate level features are a good account for how people determine which actions are similar and different. So overall, these findings suggest that perceived action similarities are best predicted by both intermediate level features and a new model of semantic features which builds on recent advances in natural language processing. So right now we're following up on this pattern by asking what kinds of semantic features are most important for how we see those actions. So far, our recent results suggest that the actor's goals have a really big influence on which actions appear similar or different. And this suggests that even when we're just casually viewing an action, we're automatically processing the mental lives of the actors performing those actions. Thank you for your time and attention, and please let me know if you have any questions.